Hey everybody, here is number 76. We're going to do 3 per video, so the videos won't be forever long. So let's take a look at what this is saying. So we have f prime of x is positive and increasing. So what does that tell us? So first of all, let's look at the first condition. F prime of x is positive. We should know if any derivative is positive, then what is the derivative of is increasing. So that tells us f is increasing. All right, let's look at the next one. It tells us f prime of x is increasing. But we know if any function is increasing, its derivative is positive. That makes the derivative of the derivative positive. But we also know if the second derivative is positive, then f is concave up. So we're looking for the region that's increasing and concave up. So where is that? Well, let's look at E. F is clearly increasing at that point, and F is also clearly concave up at that point. So we have our answer, E. All right, let's look at number 77. We know the function's continuous on this closed interval, and we're given the two endpoints. And they say, what is guaranteed by the intermediate value theorem? So a few things going on here. Let's take a look. What is the intermediate value theorem? Let me draw a little picture for you to help you remember. So we are given a function, and we're told we have 210. So at 2, I'll just pick a point up here. We'll call that 10. Then at 4, we're at 20. So there could be a lot of different graphs that go between those 2 points. All we know is continuous, so it could look like that. Another possibility, it could be more of a direct connection. So we don't know what it looks like, but all we know that is it's continuous and those are connected like that. So what can we say here? So what does the intermediate value theorem say? Basically that this function, whether it's the blue one or the green one or any other one connecting them, has to cross every point between 10 and 20. If there's no jumps, gaps, discontinuities, it has to cross every value. It doesn't guarantee anything below 10 or above 20. It might go there, as you can see from the blue one, but that is not guaranteed. And we're going to go backwards here. Does the intermediate value theorem guarantee that the derivative will be positive? Well, for the derivative to be positive, that means the function have to be increasing the whole time, but we are not guaranteed an always increasing function. The intermediate value theorem has nothing to do with an increasing function, so we'll ignore that. Now, part D is kind of a tricky question because that's kind of related to the mean value theorem. The mean value theorem says the derivative will equal the average rate of change. So if I do f of 4 minus f of 2 over 4 minus 2, which would be 20 minus 10 over 2, which is 10 over 2, which is 5, we might say, hey, we are guaranteed that the derivative has to be 5 at some point between 2 and 4. But first of all, that's not intermediate value theorem. And secondly, the mean value theorem requires differentiability between the endpoints, and we don't even have that. So for 2 reasons, this is out. C, f attains a maximum value on an open interval. You're not guaranteed a maximum on an open interval Let me just show you real quickly. Say that's 3. That function does not have a maximum because there's an open at the y value of 3. So if you say, well, the maximum is 2.999999, well, I'll say no, because 2.999999 is bigger than what you picked. You can't pick a biggest number smaller than 3. It's not possible. So even if they gave you a closed interval, now the extreme value theorem guarantees a max and min. But again, they're asking for the intermediate value theorem, not the extreme value theorem. So that's out. Okay, this one seems like a good one because 15 is between 10 and 20. But the problem is that we don't know where it's going to cross 15. It could be any number between 2 to 4. You're not guaranteed at a specific point, so it can't be B. 13 is between 10 and 20, and that is the one we're looking for. The answer in that one is A. We'll do one more of these. All right, what are they looking for here? They want the slope of the graph at the point where this graph crosses the x-axis, and it's between 0 and 1. So first of all, to find the slope, basically it's asking for the derivative at that point, which we'll call A. That gives you the slope of the graph. So now we have to find where this graph crosses the x-axis. So in your calculator, under y1, plug in your graph. And then on my windows, I'm going to set my windows from 0 to 1 because the problem says from 0 to 1. And since I want to know where it crosses the x-axis, I don't have to see the whole graph. I'm just going to graph the y min from -1, y max to 1, just to see where it crosses the x-axis. And then if I graph that, your graph should look something like that. So we're looking for that point. So on your calculator, do second trace, and you're going to find the 0. And if you go through the steps it asks you to, you should find this point here occurs at 0.6061193. Store that in your calculator, so go to your home screen, take X, store A. Now all you have to do is do math 8 to find the derivative. Plug in y1 for your function. I'm assuming that's where you put your function. And alpha A, the number you stored. And that comes out to be 2.960912557. And that gives us an answer of D.